Very good morning, students. Today we will discuss about haloalkanes and haloarenes, the first chapter from book 2 of your textbook. We are going to take organic chemistry, and the first chapter is, I told you, haloalkanes and haloarenes. Dear students, what do you mean the term haloalkanes and haloarenes? Haloalkanes are also known as alkyl halide, alkyl halides, and haloarenes are also known as aryl halides. You know, alkyl is the R and halide is the X, and aryl halide is the AR and X. Thus it is very clear, R stands for the root word of the aliphatic series. Methane, ethane, propane, butane are considered as the R, and AR means aromatic series that starts from benzene. That is why I have written here RX. R can be methyl, X stands for the halogen. So it is the methyl chloride, C2H5Br. R is going to change, methyl. Instead of methyl we take ethyl. Ethyl bromide. X stands for the halogen, fluoro, chloro, bromo and iodo. Fluoride, chloride, bromide and iodide. That is why I used to change X. C3H7 iodine, C4H9 fluorine, butyl fluoride, propyl iodide, ethyl bromide, methyl chloride. But this side, simply you take benzene, and what's the formula of the benzene? C6H6, H6, replace the 1H and add the halogen. Now it forms, it is what? Phenyl chloride, C6H5 and halogen, phenyl chloride. Or we can say phenyl halide. Halide stands for chloride, bromide, or it is benzene, and benzene once replace 1H it becomes phenyl. Don't say benzyl. Benzyl is different from phenyl. So here that is the aromatic, it is arene. So this is called as aryl halides or phenyl chlorides. So this is the introductory part of the haloalkane. Now how do you define the haloalkane, and then we'll discuss haloarene. Haloalkane means there is replacement of the hydrogen from alkane by the addition of halogens are known as haloalkanes. So I write first, what is that? Haloalkanes. Haloalkane means replacement of hydrogen or hydrogens from alkane by the addition of halogens. X stands for halogen, called haloalkane. For example, you remember the chain reaction. Methane undergo chlorination or bromination in presence of sunlight or ultraviolet rays. That is why we take here methane undergo chlorination in presence of UV rays. HCl is lost, CH3Cl. Further they undergo chlorination, again HCl, dichloromethane. Further undergo chlorination, trichloromethane, or this is known as, what is that? Chloroform. And finally further undergo chlorination in presence of ultraviolet rays or sunlight or heat, we get HCl, CCl for tetrachloromethane. So that is what it is. The students, methane undergo chlorination, chloromethane, further chlorination, dichloromethane, trichloromethane and tetrachloromethane. This is known as chain reaction, and these are separated. These mixtures are separated by fractional distillation. Fractional distillation. Okay. Then classification of haloalkane. As the classification is concerned, you remember haloalkanes are of three types: primary, secondary and tertiary. Three types of the classification. First is the primary. Primary is called as 1 degree alkyl halides. Secondary means 2 degree alkyl halides, and tertiary means TERT, terts, or tertiary, that is stands for 3 degree alkyl halides. So once you write 1 degree, that is RCH2X. When the halogen is linked to X, that carbon containing 2 hydrogen. When hydrogen is linked with only one carbon, when carbon is linked with one carbon at the same time, it is 1 degree carbon. So 1 degree alkyl halide means the halogen linked with the carbon containing how many hydrogen atoms? 2 hydrogen atoms. That is the identification of primary alkyl halide. So far as secondary is concerned, you write 2R, CH and X. There is only one H. In primary 2 hydrogen atoms. In secondary 1 H and 2 alkyl groups. And tertiary R and here write carbon and halogen. There is no any hydrogen. So classification of haloalkanes are of 3 types: primary, secondary and what? Tertiary. I write here CS3, CH2Cl, which is called as ethyl chloride. Or in IPAC system, chloroethane. You know the name, chloroethane. I write here CS3, CH, Cl and CS3. Is it 2 degree alkyl halide? Yes, of course, because of carbon contains only one hydrogen where there is halogen. So it is the iso, common system is the isopropyl, and what is there? Chloride. In IPAC system, you consider the longest chain rule and near the substitution. First you select the longest chain rule. It is the 1 carbon, 2 carbon or 3 carbon, or either you say 1, 2 and 3. This is the 1, this is the 2 or this is 3. You proceed any side, you are getting the chloro at the second point. Therefore in IPAC system, it is 2-chloropropane. And then finally, so far as 3 degree is concerned, it is the tertiary or tert. You write here CS3, CH3, C and Cl. Fluoro can be changed into bromo, bromo can change into fluoro, and so on. Therefore it is the common system में, in common system it is tert or tertiary 1, 2, 3 and 4 butyl, tertiary butyl chloride. But anyone tell me IPAC system? It is the 1, it is the 2 and it is the 3. Select the longest chain rule, substituent must be nearer, and if you are getting 2 or more different substituents, then as per the IPAC norms, you consider them as alphabetics. Alphabetically, chloro comes before methyl. So at the 2 locant, there are 2 substituents. One is the chloro and other is the methyl. C comes before M. That's why we have right here 2-chloro, 2-methyl propane. It is the IPAC nomenclature. So write down 2-chloro, 2-methyl and which is the propane. So this is the classification of the alkyl halides based on primary, secondary and tertiary carbon. Here the another part is very important. If you have to classify them, then you again consider all the alkyl halides are classified based on sp3 hybridization. If there is a single bond between carbon and around the carbon, 1 sigma, 2 sigma, and if I write this hydrogen in this form, CH and CH like this, single bond is sigma and sigma. So if you are getting 4 sigma, around the carbon, then hybridization is sp3. If you are getting 3 sigma, you say carbon is sp2 hybridized, and if you are getting 2 sigma, carbon is sp hybridized. 4 sigma sp3, that is the tetrahedral, having bond angle is 109 degree 28 minutes. In sp2, if you are getting 3 sigma around the carbon, top, bottom, left and right, single bond represents sigma, double bond represents 1 sigma and 1 pi, and triple bond represents 2 pi and 1 sigma. Not more than triple covalent bonds are possible in organic chemistry. See here, in carbon and carbon. So there it is the trigonal, and what the bond angle? 120 degree, and sp is the linear and 180 degree. So how many sigma in primary halide? 1 sigma, 2 sigma, 3 sigma and 4 sigma. So what is your answer? sp3. Here 1 sigma, 2 sigma, 3 sigma and 4 sigma. Again sp3, 1 sigma, 2 sigma, 3 sigma and 4 sigma, sp3. So dear students, if you calculate the type of hybridization, you can go for sigma, sigma and sigma. And carbon does not exceed more than sp3 hybridization, because carbon does not have vacant d orbitals. Because of carbon has only 2 energy level, so it contains only s and p orbitals, not d orbitals. So for your kind information, all the organic molecules must contain carbon, and carbon should be hybridized as sp, sp2 and sp3, but never sp3d, d2 and d3. Is it clear? Now this is the classification of haloalkanes based on monohalogen derivatives. Now classification for dihalogen derivatives. That is, dihalogen means 2 types of the compounds. One is the geminal, it is known as gem, and other is the vicinal or weak dihalides. So if the same carbon contains 2 similar halogens, then it is called geminal or gem. At the same carbon, I write here like CH2, Cl and Cl. It is called as common system methylene chloride, or IPAC system 1 and 1, 1 comma 1, dichloromethane. It is geminal halide. If I write CS3, then CH, PR and PR. It is ethylene dibromide, or IPAC system. It is the 1, or it is the 1 comma 1. How many bromo? Dibromo ethane. Right? If I say CS3, C chloro and CS3. Again, same carbon contains 2 similar halogens. So it is again geminal or gem. That is 2,2-dichloropropane. IPAC system is 2 comma 2 dichloropropane. Come to the vicinal, CH2Cl and CH2Cl. It is the vicinal. 1 and 2. Ethylene dichloride. In common system, it is called as ethylene dichloride, or in IPAC system 1, 2 dichloroethane. Adjacent point containing similar halogens, it is weak or vicinal. Further I write here CH2Br, CHBr and CH3. Again it is vicinal. 1, 2 and 3. 1, 2 dibromopropane. So write the IPAC name. 1, 2 dibromo. What is that? Propane. Or is it vicinal? Tell me anyone. CH2Cl, CH2 and CH2Cl. It is vicinal? Anyone? No. It is not vicinal because there is a gap of the halogen in the halogen. Halogen must be present at the adjacent point. That's why it is called vicinal or weak. But this is not vicinal. This is, and these are vicinal. So dihalogen derivatives are of two types. One is the geminal and other is the what is that? Vicinal. Similarly, trihaloalkanes. Trihaloalkane means 3 halogen atoms present on the carbon here. So in case of trihaloalkanes, that is known as haloform. Haloform. Their strengths here CH, Cl, Cl or Cl. That means CH, Cl3. That is called as, what is that? Haloform is what you say, chloroform. CH, bromine, bromine and bromine. CHBr3. What is that? Bromoform. And similarly, CH iodine 3 times CHI3 act as a antiseptic and used in the iodoform test. So this is the iodoform. Iodoform. These are the classification of trihaloalkanes. And finally, tetrahaloalkanes. That is 4 halogen atoms like CCl4, CBr4, carbon tetrachloride, carbon tetrabromide, carbon tetrachloride, and there you write here carbon tetrabromide. Here it is the tetrabromide, but it is the tetrachloride or tetrachloromethane. It is used in the fire extinguisher, carbon tetrachloride. So their strengths, these are monohalogen, dihalogen, trihalogen and tetrahalogen. Monohaloalkanes are of 3 types: primary, secondary and what? Yes, tertiary. 1 degree, 2 degree and 3 degree. 1 degree was characterized by RCH2X, 2 degree is characterized by R2CHX and 3 degree is characterized by R3CX. Primary, secondary and tertiary. See, if I give you a question here, draw the structure of 1 bromo, 2 methyl, 4 tertiary butyl benzene. So here first write 1 bromo, take it alphabetics, 1 bromo, 4 tertiary butyl. Tertiary is not taken as alphabetics, but B is taken as alphabetics. Tertiary, primary and secondary are the prefixes. But the root word starts from the word that is to be taken as alphabetics. 1-bromo, 4-tertiary butyl, 2-methyl, 2-methyl cyclohexane, suppose, or benzene, whatever it is. If I write first cyclohexane, 1 can be any point, can be 1. It can be 1, it can be 1, it can be 1. Any point is 1 because it is cyclohexane like benzene is symmetrical. 2-methyl, 2-methyl, 4-tertiary butyl. Dear students, this, if I say tertiary, how many R should be there? Tertiary stands for 3R. Now you change the R and you add the methyl group. Because our question is tertiary butyl. But means how many carbon? But means 4 carbon. 1 carbon is already added in that formula. So here you replace the R, methyl. Further you replace the R, methyl, and it is the methyl. So 1, 2, 3 and 4 are tertiary butyl. If I say tertiary pentyl, then you replace 1 R, methyl. Now you can add ethyl. Tertiary pentyl, like this. But if question is based on tertiary, there are only 3 R's. R can be modified because you have a long list of R: methyl, ethyl, propyl, butyl, pentyl, hexyl, heptyl, octyl, nonyl, decyl. Is it clear? Now therefore, if I say 1-bromo, 4-tertiary butyl, 2-methyl, and I replace it is simply benzene. So here you write benzene. Now it is benzene because of circle or ring is there in benzene. Therefore it is 1-bromo, 4-tertiary butyl, 2-methyl, benzene is alright. Right? If I say 1-bromo, now I change the question and I write here, say 1-bromo, 3-ethyl and 4-isopropyl benzene. So first you draw the benzene. I can say 1-bromo is alright, 3-ethyl, C2H5, and it is the isopropyl, or you can say 4 secondary. If I change it like secondary butyl, 4 secondary butyl. If I write secondary butyl, R should be 2 and H is 1. Tertiary means 3R, no hydrogen. Secondary means 2R and 1 hydrogen. Primary means 1R and CH2. Again in nutshell, just you keep retain in your memory. It is primary, it is secondary, and it is what? Tertiary or third. In tertiary, 3 alkyl groups. Secondary, 2 alkyl and 1 hydrogen, right? In primary, 1 alkyl and 2 hydrogen atoms, right? So primary, secondary, 1 degree, 2 degree and 3 degree. So here my question is the secondary butyl. See this point. But means 4 carbon, 4. Here there is 1 carbon. So you replace 1 R, either write here ethyl or methyl, and this R is again replaced by methyl. So but means 4 carbon, 2 carbon is here. Point to be noted, 1 is here, 3 and 1 is 4. It is, you know, secondary butyl. If I say 4 secondary pentyl, then you can replace this methyl into ethyl. So this is the classification of primary, secondary and tertiary. Now classification of radicals based on hybridization, like benzylic red, benzylic halide. It is characterized by sp3. Dear students, if you see the benzylic radical, now this is the toluene or methyl benzene, replace one H, then its formula becomes CH2. It is known as benzyl. Right. So keep in your mind, whenever side chain hydrogen is replaced from the toluene, first radical is benzyl, and then if you add it here X, right? So that means how many, I write here this compound in that form, CH2 and X, sigma, sigma, sigma and sigma. How many sigma? 4. So your answer should be sp3 hybridization. So it is the 1 degree benzylic radical. I can say here CH and R लगा दिया और X. What degree benzylic radical? 2 degree. Again it is sp3 hybridization, but one H is replaced and alkyl group is added. Further sigma, sigma, single bond is sigma. So 4 sigma around the carbon. So sp3. But it is 2 degree benzylic radical. Why it is 2 degree benzylic radical? Because of one H is present on the carbon where there is halogen. And if I say 3 degree benzylic radical, 3 degree R may be same or may be different. It is 3 degree. So benzylic radicals are characterized by sp3 hybridization. It can be primary, it can be secondary, or it can be what? Tertiary. Is it clear? Now next is the allyl radical. Allylic halide. Again it is characterized by sp3 hybridization. Dear students, allyl represents CH2CH, then you write CH2X. With respect to carbon-carbon double bond, the halogen linked with the carbon must contain sp3. How? Sigma, sigma, sigma and sigma. So this is the sp3. It is the allyl. It is the allyl halide. Now it is 1 degree allyl halide. If I write CH2 double bond CH, and but I write here R and X. What degree allyl halide? 2 degree, because of 1 H is present here. Again hybridization is sp3. And if I write tertiary allyl halide, R and X, it is tertiary. So primary, secondary and tertiary. One question comes in CBSE paper. What kind of this halide? Anyone tell me? What kind of this? With respect to carbon-carbon double bond, with respect to the carbon here contains, because H is silent here, sigma, sigma, sigma and sigma. So this carbon has what kind of hybridization? Guess friends, sp3. So it is again allyl radical. Allyl radical. So benzyl, allyl and alkyl are, sp3 hybridization. Now next is the vinylic radical. It is sp2 hybridized. Once you write the vinyl, CH and X, double bond carbon containing halogen is the vinyl. But allyl, not like that. Allyl means with respect to carbon-carbon double bond, next carbon contains halogen. Vinyl is sp2 hybridized carbon, whereas allyl was sp3 hybridized carbon. Dear students, here one thing is very clear. It is the sigma and it is the pi. But this H can be written like this: sigma and sigma, 1, 2 and 3 sp2. CH2 double bond CH and Cl. It is very important compound in common system. Vinyl chloride. Once you replace the chlorine and add the OH, you can say vinyl alcohol. So far as impact name is concerned, 1 chloroethene One stands for chloro and one carbon, there is double bond. So one chloroethene, right? Now, what kind of this radical? Double bond containing halogen. Of course, sigma, sigma and sigma. So it is sp2. Again, it is the vinyl radical. Now, last is the aryl or phenyl radical. As I told you earlier, when you replace the hydrogen from the benzene, it is not benzyl. Never say benzyl, phenyl or aryl. So, aryl radical. I say benzene, replace one H and this one. It is sp2 hybridized. Sigma, this circle means alternate pi bond in benzene. You know it very well. Therefore, it is sp2. Sigma, sigma and sigma. In benzene, 3 sigma and 12 pi in the benzene. We don't consider the pi for hybridization in the organic molecule. Always you carry the sigma around the carbon, and if there are 2 sigma, sp3, sp2, 4, sp3, is it clear? So it is sp2, aryl halide, right? So these are the different classifications of the haloalkanes: 1 degree, 2 degree, 3 degree, dihalogen, geminal and vicinal. Trihalogen means haloform, chloroform, bromoform, iodoform. And so far as you know, radicals are concerned, sp3 hybridized carbon are, benzyl radical, remember it, allyl radical and alkyl radical. All are 1 degree, 2 degree and what degree? 3 degree. Right? sp2 radical represents only 2. What is there? sp2, yes, vinyl and phenyl. Vinyl radical and phenyl radical. And there is no any types 1 degree, 2 degree and what? 3 degree.